So good morning guys. Our activity for today is all about the foundation plan. So we will create a structural foundation plan. So based from the given problem, so the dimensions for isolated footing is equivalent to 3.4 meters by 3.4 meters. Then the rebars is equivalent to 20 millimeter diameter at 175 mm both ways. Then for the concrete cover, so concrete cover is equivalent to 75 mm. Then we will have also a 50 millimeter lean concrete. Then depth of bottom of footing from NGL with equivalent to 1.5 meters. Then thickness of footing equivalent to 500 mm. Then for the combined footing, so dimensions of combined footing is 6.5 by 3.5 by 0.5 meters. So the length is 6.5, the width is 3.5, and the thickness is 0.5 meters. So for the reinforcing bars, so at x-axis, the top rebar is equivalent to 20 millimeter diameter at 150 millimeter on center. Then for the bottom rebar, so 20 millimeter diameter at 100 millimeter on center. Then at y-axis, top rebar 20 millimeter diameter at 300 millimeter on center. And for bottom rebar, 20 millimeter diameter at 150 millimeter on center. So the concrete cover is equivalent to 75 millimeters. Then we will have also a 50 millimeter lean concrete. Then depth of bottom of footing from NGL is 1.5 meters. Thickness of footing is 0.5 meters. Then for the column that is supported by the foundation, so the dimension is equivalent to 0.575 meters by 0.575 meters. The reinforcing vertical bars is equivalent to 12 pieces of 25 millimeter diameter. Then for the ties, 12 millimeter at 100 millimeter, so we will have 3 sets of ties. Then for the concrete cover, so concrete cover is equivalent to 40 millimeter. Then for the slab, for the ground floor slab, 100 millimeter thick slab on fill with 10 millimeter space at 350 both ways. Footing tie beam and beam at support. So at support, dimensions is equivalent to 250 by 450 millimeter. Then the rebar for top bars is 3 pieces of 20 millimeter diameter, and for bottom bars is 2 pieces of 16 mm diameter horizontal bar. Then for the stirrups, so stirrups is 1 at 50, 2 at 75, rest at 100. Then concrete cover is 40 mm, and for the footing tie beam and beam at midspan, dimensions is 0.25 by 0.45 meters. So rebar at bottom bars is 3-20 millimeter bottom bars and 2-16 millimeter top bars. Then stirrups, 1 at 50, 2 at 75, rest at 100. So concrete cover is 40 mm. So this is an example problem on how to create a structural foundation plan. Then next, so going back to our sheet in AutoCAD, so first thing we should do is locate the exact location of the column. So checking the architectural plan. So here is the example of the architectural plan for ground floor plan. Then typical second, third floor plan. Then next for the front elevation, this is an example of a school building. Then rear elevation, left side elevation, right side elevation, then cross section, longitudinal section, reflected ceiling plan of third floor, then roof plan, and so on and so forth. So to determine for the exact location of the column, so based from the architectural plan of ground floor plan, the location of the column is within the intersection of the grid lines. So we need to copy the grid lines. So to copy for the grid lines, so simply copy the grid lines that is based from the architectural plan, or you can redraw it. So ako, i-copy ko na lang siya. So I'll just copy the grid lines. So copy. So grid lines at x, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and at y, which is A, B, and C. So ayan, copy ko lang yan. Then ito. So ayan. Then next, so Control C. Oh, Control C. Try again. Let's try again. Then A, B, and C. Control C. Then paste in your separate sheet. Copy. So I'll just copy the whole architectural ground floor plan, then paste it in our structural sheet, and okay. Then CP for copy, CP for copy. Then copy ko yung grid lines 1 to 11 and A, B, and C. Then move ko siya. So, then next, is extend natin yung line. So we need to extend the lines. So for A, so type XL. So XL for extended line, then B, then C. So in order for us to determine the intersections. Then next, XL for grid line 1, then 2, then 3, and so on and so forth. Then copy ko na lang siya. Then 5, 6, 7, 8, 9, 10, 11. Then erase. So ayan. Then next, so going back at the architectural ground floor plan, so the location of the column is in the intersection of the grid lines. So ayan. So next step, so copy ko na lang yung ating columns. So columns is the blue ones. So ayan. So copy, ayan. So copy, then copy. Ayan. Kaya lang, so naka-group siya. So it means we need to ungroup this one or explode this one. So simply type EX for explode, then click the object. So explode ko na lang lahat. Then enter. So ayan. So explode. 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 Ayan. So never mind since we don't need this one. Then next, so copy na lang natin yung columns. So copy. Copy na lang natin siya. So, copy. Ayan. Then paste ko siya doon sa exact location of grid line 1-A. Ayan. Then next, so the other column. So copy lang din natin yung other columns. So copy. So kita mo na since our column here is not at the midpoint of this shape. So that's why we need to separate. We need to copy this one separately. Copy. Ayan. Then paste it at grid line 11. Grid line 11. Ayan. Okay. Then next, so the other columns. So our other columns, uh, copy, then locate the midpoint, CP, CP, then paste it at the intersection. So, ayan. So then next, so let's check what is the dimension of the column that the architect has set up. So type DI for distance, then click at one point to the other point. So the dimension is 0.35. However, the structural engineer has a resulting design of column for about 0.575 meters by 0.575 meters. So we need we need to change the dimension member of the column. So type REC, then dimensions for D, then the dimension is 0.575 by 0.575. So REC, then dimension 0.575 by 0.575. So ayan. Then next, move lang natin siya. Move, determine the midpoint, and ayan. So here is our new column. So this is the structural column that will be used. Then next, so let's pick the layer for column. So just search for column. So ayan, color blue yung ating column. Then erase this one. Ayan. Then copy. Copy lang natin siya. 1, 2, 3. CP. 1, 2, 3. Copy, copy. Ayan. And so on and so forth up to grid line number 10. Then next, so we need to change these dimension members for grid line 1. So, so as a structural engineer, so you can negotiate with the architect if you can change the location of the columns. But for this example, so we will follow the architect's uh, exact location of column. So determine the midpoint of the column. Then next, so type copy, then paste it at the midpoint of the column. So ayan, then erase. Then next, so ganun lang din. So CP, then at the intersection, so paste, then paste, then erase. Ayan, erase, and erase. Then next for grid line 11. So for grid line 11, so mirror na lang natin siya. So mirror. Hanapin natin yung midpoint. So 9, 1 to 11. So for the midpoint, ayun. Nasa grid line 6. So erase natin siya. Erase, erase. So erase, erase, and erase, erase. Then type MI for mirror. Then click the columns at grid line 1. Then locate for the midpoint of this line. Then okay. Ayan, ano na tayo? Column at grid line 11. Then next, natin siya Brian. Then next, so we need to draw the isolated footing. So the dimension of the isolated footing is 3.4 by 3.4 meters. So type REC or rec, then dimension, so 3.4 by 3.4. So ayan. Then next, so locate for the midpoint of the isolated footing, then move natin siya at the intersection of the grid lines or at the midpoint of the column. So, ayan. So here is our isolated footing number 1. Then next, D, ay, REC, then D, 4 by 3.4. So next, so move lang natin to. So move, then locate for the midpoint, then paste it at the midpoint of the column. Then type copy, CP for copy, and paste lang natin siya from grid line 1 up to grid line number 10. Ayan. Then next, so MI for mirror. So mirror natin yung isolated footing number 1. Then wait for the grid line number 6 and paste. And paste. Ayan. Then next, so we are done with the isolated footing. So next step is to draw for the combined footing. So the dimension for the combined footing is 6.5 by 3.5 by 0.5 meters. So check natin what is the meaning of combined footing. So combined footing. Here is the example of a combined footing. Combined footing is basically a combination of various footing which utilizes the properties of different footing in a single footing based on the requirement of the structure. So it carries two or more columns along a straight line. So here is the examples of the combined footing. So ayan. So if the distance between the columns is not that big, so we will need to have a combined footing. So ayan. So here's the examples of the combined footing. Then next, so going back, so the dimension of the combined footing is 6.5 by 3.5 by 0.5. So type REC, then dimension, so 6.5 by 3.5. Then the orientation of the combined footing must be along the, so the longer side must be parallel to the y-axis. So REC, then type D, so 6.5 by 3.5, then enter. Then let's rotate the shape. So RO for rotate. So RO, then type click the object, then okay. Then next step, so we must determine the midpoint from B up to C. So type L for line, then click from point B up to point C. Then next, so we can determine the midpoint from point B up to point C. Then next, so we must also locate the midpoint of the combined footing. So type a line or make a line, then move the combined footing to the midpoint of the two different columns. So ayan. So here is our combined footing for grid line number 1. So ayan. Then erase lang natin dyan. Then next, so MI for grid line 11. So MI, then wait for the midpoint. Ayan. Then paste. Then for grid lines 2 up to 10, ayan, copy lang natin siya, then CP, then wait for the midpoint. So wala pa na siya, wait for the midpoint. So ayan, then copy natin, copy na lang natin siya, 3, 4, 5, 6, 7, 8, 9, 10. So ayan. Then next, so we are we are already done with the isolated footing and combined footing. So we are also done with the column. So next thing is the footing tie beam at support and at midspan. So the details for support at midspan will be seen in the typical elevation view of the beams and footing tie beam. So for the footing tie beam, so the dimension is equivalent to 0.25 by 0.45 meters. So it means we need to determine for the base of the beam. Ayan. So the beam width is equivalent to 0.25. So assuming that the structural engineer has set up the footing tie beam at all connections of the column. So for the footing tie beam, so locate for the midpoint of the isolated footing. Then next, so the width is equivalent to 250. So it means, so we need to draw for the half of the 250. So for the footing tie beam, so the width of the footing tie beam is 250. So first, so 0.125 at the left side or at the upper side. Then next, connect natin sa kabilang column. Then 0.125 again at the lower side. So total niyan is 0.25. So ayan. So here is our footing tie beam from grid line 1 up to grid line 2. Then next, so since the distances is equal, so copy lang natin siya. So CP, so type CP, then paste it at the other side of the column. So ayan, paste. So paste lang natin siya sa lahat. Paste. Ayan. Then next, so copy lang din natin siya. Since equally distributed lang yung ating distances. So, copy, copy, copy. So, copy, copy, copy. Ayan. Then, paste lang natin siya. Paste lang natin siya at the midpoint of the column. Ayan. Ayan. Okay, so we have already the footing tie beam for the foundation plan. Then next, so at y-axis, so ganun lang din. 0.125, then extend up to grid line B, then 0.25. 0.25. So ayan. Then okay. Then trim natin. So trim, then erase. Then next, so copy lang. Copy. Copy lang natin siya. Copy. 3, 4, 5, 6, 7, 8, 9, 10, and 11. Ayan. Then next, so for grid line B up to C, so tayo. So for the footing tie beam for grid line 1 up to C, B up to C, extend lang natin yan. Then trim na lang natin. So trim or erase. Then, copy. Copy, copy. So, copy. Copy lang. Copy, copy, copy. Then, trim. Trim lang natin. Trim, trim, trim. Then, trim. Then, ito, erase. Then, CP. CP. 5, 6, 7, 8, 9, 10, and 11. So, yan. Then next, so next step is for the slab. So based from the given problem, so the slab is 100 millimeter thick slab on fill with 10 millimeter space at 350 both ways. So to create for the detail of the slab, so type circle, then next, so any type or let's just set a diameter for the circle. So circle, then diameter of 1 at any location from 2 to 3. Then next, so we will make rebars. So we will make a set of rebars. CP, and assuming that the spacing of the rebars is 350, so 0.35. Then offset na natin. So offset, then offset, then offset, then 0.35. Then next, so ganun din sa x-axis. So offset 0.35. So on and so forth. Then trim lang natin. Then extend. Then trim. Trim. So yan yung magiging itsura ng rebars natin for the slab. Trim. 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 Ito, extend. Extend. Ayan, extend. Then trim. Ayan. So, we are already done with the foundation plan. So, kulang na lang natin is the text. So, for the text, so type text for text. Then, click from one point to the other point. Then, type 100 mm thick slab. Medyo malaki na. So, then move natin muna siya. Medyo malaki. Then, SC for scale. So, let's say 0.05. Medyo maliit. SC 0.05. Ayan. Then, move. So, medyo malaki pa rin. So, pwede pa natin siya scale. Thick slab. Sabi? On fill. CP. So, CP yan. Natin ko na lang din. Edit. On fill. With 10 millimeter diameter spaced CP ulit spaced at 350 millimeter on center both ways. Ayan. And scale, since medyo malaki pa siya, 0.5. Medyo malaki pa rin. 0.75. Ayan. Then move. Then move natin. So, green lang natin siya dito. Ayan. trim na natin lahat ng extended lines. So, trim all of the extended lines, then erase. So, ayan. And ito, trim din natin yan. Ayan. So on and so forth. Then next, so let's copy the layers that is based from the architectural plan. Ayan. So, ito, beam. So, assume na lang natin siya na ang layer niya is medyo makapal. Foundation. Wala. Foundation. Assume na lang natin na properties color, so yellow, since all of these colors has its own thickness when printed in A3 paper. So ayan. So for red, then yellow, then green, then cyan, blue, and magenta. So the thinnest one based on this layer is the gray, followed by the white, then red, then yellow, green, cyan, blue, magenta. So the thickest one is the magenta. So let's assume that the color of the foundation or isolated footing is yellow. Then MA for match properties. So click MA or type MA, then click this property of the isolated footing, then click it to the other footing. So para magparehas sila na. Ito na. So on and so forth. So, up to grid line number. Then next, so the line weight of this slab, so assume na natin siya na blue. Then for the beams, so let's assume it as green. So MA for match properties, MA up to the last member. Ilan pa? Ang dami pa. And ito. Ito pa. And so on and so forth. Ayan. Ayan. Then next, grid line B. Grid line B. So pwede pa natin siya i-trim. So yung trim this one. So para mas maging presentable yung drawing. However, since this one is only editorial, so ito na siya i-trim. Then next, ito na rin. Samahin ko na. Ito. Then I change the color of the grid lines. So for the color of the grid lines, so it must be thin when printed. So properties, then red. So show mo siya as red. Trim ko ta. Erase. And erase ko pa. Erase. Then copy. 6, 7, 8, 9, and 11. Ito rin. So, MA for match properties. Ayan. Then, this. So, ayan. So, here is the example of our foundation plan. Ito, turo na lang ito. F8 or ortho. Ayan. And for the dimensions, so for the dimensions, dito na siya nakuha na. Copy ko na lang. Copy. 4, 5, 5. Or type DLI for annotation. DLI. Paste grid 10, grid 9, 10. Yeah. Okay na. Then next, so A, B, and C. A, B, and C. So copy ko na ito. And ito na lang copy ko. B and C. Ayan. The distance from A up to B is 7. Means ito is 7,000. Ayan. And move natin siya sa midpoint. Ayan. And next, ito yung kulang. Kulang natin is the text for the foundation. So for the text, so type text, text. Or ito na lang, let's just copy this one. Then next, edit. So ito, so footing 1, so assume natin siya as isolated footing number 1. Since we have two types of footing, which is isolated and combined footing. So F1 as isolated footing number 1. So, ayan. So footing 1, then copy. Copy na sabay-sabay or simultaneously. Then next, so copy. Isang copy na lang. Copy. Copy natin. Then, paste. Paste na nga siya. Ayan. Mali pala. So, this is a combined footing. So, paste na natin. For combined footing, so we will type it as CF1. Or we will mark it as CF1. CF-1. Ayan. CF1. Erase ko na sila. CF1. And CF1, CP, copy, up to the very end of grid line 11. Then next, so ang kulang na lang is yung footing tie beam. So for the footing tie beam, so we will type FTB-1. So, ito, FEB-1 denoted as footing tie beam number 1. Then, copy. Copy lang natin siya. Copy. Yan. Yan. Ito. Next. CP. Node. FEB-1. Ayan. Paste. Paste natin siya dito. Ayan. Then at y-axis, so CP. So CP. Paste natin siya dito. And rotate RO. And then move. Move. Ayan. Then CP ulit. Then midpoint. Then copy again. Copy. Up to grid line number 11. Then, ito. B-1. Green line number 11. So, here is the example of a structural foundation plan. So, ito na yan. Ito na yung ating foundation plan. So, for questions and concerns, so kindly message na lang at our group. So, that's all for today and thank you. So, ayan, foundation plan.